I'm Priyanka, and I work on the OpenTracing project, as well as at LightStep, where I had product marketing. And I'm here today to talk about distributed tracing in the world of containers, and discuss a little bit the standards-based approach that OpenTracing takes. Fair warning, I'm not a Kubernetes expert, so just keep that in mind as we go through this. All right, so what is tracing and why care? So at the very highest level, tracing will tell you a story of a request as it passes through various components of a system, which is most likely and potentially distributed. From the request perspective, this is going to explain what's happening within each service, which is done via spans, which are similar to logs, just a timestamp start-stop, and also what's happening between services, which is done through context propagation, which does exactly what its name says, propagate the context. So this is a bunch of words, so I thought visuals might help clarify better. So if we look at concurrency on the right, well, yeah, you're right. So the right side graph, you see a version of distributed concurrency. I'm sure most of you are very familiar with this. Excuse me. And the red dashes that you see are spans, or in a specific moment this thing happened and it was logged, just like logging. And then the dotted lines are the context propagation links, which tells you this is where the request moved and went here and then came back here, etc. So this is kind of a visualization of what tracing does. Now, why care, that part? These days, microservices are becoming big in code bases, and as you guys know, as people containerize, it's often they're also at the same time breaking up their monoliths into services and getting the tooling right for them. Microservices are here to stay. We've been talking about this for over a year now, at least. Every meetup, there's somebody talking about microservices. Here, unfortunately, it's me. Excuse me, bad throat. And of course, it makes sense, right? Because it's easier to build, easier to make the right decisions for your customers, etc. But the problem that happens is that the tooling that worked really well in the monolithic architectures, it starts breaking down really quickly. Especially from an observability perspective, these graphs kind of try to explain the problems that occur, excuse me. In the monolithic world, everything is in one place, and so you know when a request starts and then goes through various components, you can clearly see where it's going. But just break it up into fragmented pieces, as happens in a distributed system, and suddenly it's just not 100% sure which way it went, what happened, etc. And a good monitoring tool is going to tell you a complete story about what's happening in the system. So process-based monitoring is just not going to work. So this is where distributed tracing can help. It'll tell you the complete story by combining the discrete events that are spans with the context propagation, which tells you, oh, this span is connected to this one, so you can create an entire trace of what happened. So that's great. Then if this is the solution and everybody's moving to microservices, then why isn't tracing ubiquitous? Actually, just to get a sense of the room, how many people here are working on microservices right now? A ton of you, great. So I'm sure you've already started seeing all the tooling problems, if not are wildly aware of it right now. So the biggest problem that people are facing is that the information within the system is hard to get out. The simple reason for that is that when you're trying to look at a system at scale, when you really want to know everything that's happening at at complete fidelity, so you can zoom in as much as you want or zoom out as you need, then you need full information, which you cannot get with auto instrumentation. So if a vendor provides you a start-stop magic switch, which will give you some data, that's just not going to be precise enough. Then the other problem with getting the information, or instrumenting your code base to get this info is that there have been efforts that are language specific on clarifying what's happening in a language, etc. But since again you're looking at the whole code base, you need something that will tell you the story of this component as well as this component. Maybe this one's Go, this one's PHP, this one's something else. So something that's too specific to a platform doesn't work. And then there's the big problem. Most of you, well, everybody uses libraries and frameworks, so you cannot have black holes in the middle of these stories. You need to be able to tell, okay, my request started here, it went to this component, this library, this framework, which most likely is not written by you. So the handoff problem is huge. Then if you think about someone who actually solved all these problems, got the code base instrumentation right, they're not going to be very happy about the fact that everything has been so far based on specific vendors. Like, if you did all this work just to be able to try a specific solution and it didn't work for you, having to do that all over again is a nightmare, and nobody wants to do that. And this is where OpenTracing comes in. So before we jump into OpenTracing, first I'd like to do a quick history lesson. So tracing is nothing new. Since the 70s, academic research on distributed computing has been happening, which means they've been studying the tooling that works for it, and therefore distributed tracing. Brown University particularly has done a lot of great work in this space. Along the way, Google was one of the first companies to create a microservices-based architecture for their specific needs of unprecedented traffic and the way they wanted to build their system to grow certain services where it's not others, etc. But they ran into the tooling problem, and Dapper, which is their production distributed tracing system, came about. The paper for Dapper is available on the internet, so if anybody is looking to deep dive into how the current open source solutions, etc. got started, I highly recommend it. I personally really like it. It's one of my favorites. And then after Dapper, with that paper, Twitter built Zipkin, which they then open sourced in the end of the 2000s. They open sourced, and that became the first real tracing system at scale that's available open source. And then finally, in 2016, OpenTracing came along to make tracing more accessible to anybody who wants to utilize the value of it. So OpenTracing, in a nutshell, it addresses this instrumentation problem, this problem of getting information out of your very complex system and making sense of it to have complete observability. And it does so by creating a standards API. And in this talk, I'm not going to be delving deep into the spec. So if you're interested, there's a link in this talk, which I'm sure the slides can be shared later. And also, it's just github.com/OpenTracing. You can learn more about the details there. We released the 1.0 spec in August last year, so fairly young. And it solves the problem of instrumentation with an API, but for whom exactly? So obviously for developers, but one audience that benefits is application developers, people building their products who want to see what's happening in their system. That's fairly straightforward. Also, open source project owners who want to provide their users with clarity of what's happening in a system suddenly have an option. In the past, they had to build an entire tracing system, which isn't tenable, or pick some vendor solution, which means picking somebody, while now they can just instrument their framework and let the user decide whether to use tracing at all, or if so, which vendor to use, etc. And then finally, there's all the sellers, the vendors, so any monitoring solutions providers or tracing solutions providers. It's a boon for them because suddenly customers are much more willing to try things because the cost of trying different things is lower. There's a one-time upfront cost, but you don't have to do it again and again. So if we look at the OpenTracing architecture, there's the OpenTracing API, which is a thin layer excuse me, with the service that's there, with the application logics, frameworks, control packages, the RPC, etc. That's all there. And then on the other side is the actual tracing systems, Zipkin, LightStep, Jaeger, etc. Now, it's important to know that OpenTracing is just an API. It's a no-op. So when your service is instrumented with it, by itself, it's not going to do anything. It's literally just setting up the infrastructure to be able to, for the tracing systems to be able to pull and collect the data and then analyze it on their end. So all of the decision making around sampling, how exactly the insights and the analytics are working, that happens in the tracer. OpenTracing is just a thin layer to, get the data. It's like the pipe or the tunnel. What it does do is it puts together a bunch of the use cases that people have looked at traditionally separately. Logging is one example where if you just look at logs in isolation, you get a specific answer, but you don't necessarily also get to know the context. And then same for critical path analysis, same for metrics. And this bringing together of all these capabilities is, I think, one of the biggest promises of OpenTracing, because it suddenly makes your life very much easier. If you just imagine a situation where it's 3 a.m. and your page, something that gives you a complete picture is so much better than the other way around. So going back to the project and where it's at, it's young, it's 1 year old, and as I said, we announced the spec recently in August. Tracing vendors have flocked to it, so it's Zipkin compatible. Uber released Jaeger, which also Hawkular is Red Hat's APM solution, AppDash, LightStep, etc. The reason all these tracing solutions have sort of jumped on it is because of all the logos that you see. So a lot of companies have come forward really quickly to adopt this standard. Now, why is that happening? That's specifically because A, there's a lot of pain around the tooling of microservices. A lot of these companies are neck deep in using them in modern architectures, and they're seeing the cost that tooling has operationally per service and how that grows exponentially as the number increases. So finally, they see a solution of sorts. Also, it's important to note that OpenTracing came out in a vacuum where there was no other option really that was truly looking at the user's needs, such as vendor neutrality, etc. And therefore, we've got the movement that we've got from users on the application side. So all that's great, but what does it actually look like? So I'm going to dive into a demo with virtual donuts, sadly. It makes me really sad that it's virtual. We once did a demo with real donuts and it was great. So I've just built a unicorn startup. It's called donutsalon.com. It's donuts as a service. As you can imagine, such a popular thing. It's exponential hypergrowth going on right now. We've built it with microservices, and obviously because there's so much growth, we're starting to have concurrency-driven latency issues, but thankfully built with OpenTracing. So let's see where are the bottlenecks. Now, just let's understand the architecture of our product before we get into it. So it's a bootstrap company, and we just have a single donut mixer, fryer, topper. The mixer mixes the batter, the fryer fries it into a donut, and the topper puts cool toppings on it. And then all of this, it has an OpenTracing aware mutex layer, so that helps with the tracing piece. Now, one of the features of the OpenTracing API is called baggage, which lets us basically add a piece of information at the beginning of a request and carry it all through to the end as the context propagates. And we're going to use that to know what kind of topping each donut has. So as I try to do this demo, you all have been volunteered. Your help is very much required because we need to have a bunch of traction on the site to see tracing in action. So I'd request you to please take out your mobile phones or laptop, whatever, and go to donutsalon.com. I'm doing the same. And please order as many donuts as you like, 1, 2, dozen. They're virtual donuts, so it won't affect your health in any way. I really like the old-fashioned ones, so picking a bunch. Got the chocolate one, some cinnamon, glazed is good too. So please feel free to pick, etc. Okay, now let's go take part in the success disaster. So I'm gonna go to, so what we're gonna do, just so you know, is look at a couple of tracing systems and see traces in both of them, just because my donut salon is set up with OpenTracing, so I can try out different vendors. In this case, I'm going to look at LightStep and Zipkin, because that's what I've set up as at the moment. So I go to Donut Salon in my LightStep. Let's see how you guys did. Okay, great. I see that there's a spike here, which means that's what we all did. So I'm gonna go into this. And as you see here, this is like the spike in data. I want to know what the problem is, so I look at the high latency stuff, which is as you go higher up on the graph, it's obviously higher latency. Click that. And, oh wait, trace assembly. Hold on. Let's see. Oh, okay, so I'm just gonna use this one. So I cheated, I used an older one because it just explains my point better. But you guys saw the traces were real. And I can go back and try out some ones if you suggest. But basically, when you, in the browser, as you guys pushed the various choices that you have, I'm sorry?
Could you zoom in?
Oh yeah, of course, sorry. Better? Okay. Okay. So this is the entire process as it happened, right? And the yellow line here shows the critical path. In the case of Get Donut, you'll see actually this is how long it took just the browser to get the information to us. So that's just like bad internet. No offense to Vietnam. And then, like, so all of this time was just taken by the internet, which is fine. But here, when I'm starting to make the donut, then you see these are all like spans of which, as we discussed, were like just timestamp of like this happened, this happened, this happened, but they're connected together by the context propagation. And so this one is make donut, which we discussed is the process. So you have the mix batter, which is, you know, mix up the batter to make the donut, and then you fry it, and this process took a lot longer. And then finally you have the topping, which is really fast. So here we can see, well, the first problem was just it took a really long time to hit the system. But after that, it's where the frying is happening that there's a problem, and you see it's waiting behind 12 transactions. Can people see everything? Cool. And it's starting to fry cinnamon, but there's like, that's gumming up the 12 behind it. So you, in an instant, you have all of this information by just looking at one trace. Imagine if you were actually troubleshooting this, you know, at the middle of the night. It would probably make your situation a lot easier. So, and there's a bunch of data that carries with it, which you can look at, etc. So this is an example of the traces from my startup, donutsalon.com. If we want to look at traces in Zipkin, which I mentioned was the other system I hooked up my website to, we simply go to Zipkin. This is what the UI looks like here. Let me just fix up here, find traces, and there we have some examples, and you can see like everywhere the fryer is the problem, right? It's taking the longest time every time, and you can open and look at the details, etc. All right, so I just want to see if this, by the way, is the latest trace from right now. And you can see again, it's the same story where like it takes a while for the information to come from the client to the server, and then we have problems with basically the fryer. So we know all this in an instant. Now, having done this tracing exercise, I'm going to move back to the slides. what did we see? We see obviously that once you're instrumented with OpenTracing, you can use whoever you want to use for the actual data analysis. Second, we saw that how the microservices interact with each other and what the critical path was all super clear. Because we had baggage set up to the toppings, you could tell like cinnamon was the donut that was, you know, gumming up the previous ones, etc. And you had this very specific insight into a specific kind of user or whatever you want to focus on. So that's all great, but how does this relate to Kubernetes? Well, with Kubernetes, this brings us to a really great possibility with containers and distributed tracing. So spans we already discussed. It's like basically like logs, and then there's context propagation, which tells you where it's going, etc. This context propagation, which is called references here, effectively can cross through pod boundaries, and you can then get a complete picture of what's happening across the whole orchestration. I mean, as all of you have deployed a Kubernetes and seen, you're like, you know, pods coming up, going down, it's all happening really quickly, but with distributed tracing, you can potentially still get a complete